this. The electron geometry is
Oxygen?
yeah, around oxygen. How many groups of electrons are there?
There's two.
Two? What are they? Lone pair, lone pair? Or single bond, single bond? What are they? Or one lone pair, one single bond? Is that two? In other words, how are you counting two?
Single bond, single bond, single bond.
Single bond, and then we ignore the lone pairs? Get rid of those? Okay, if you include the lone pairs, then it's got to be 4 because otherwise we'd have to double count. So 1, 2, 3, 4. 4 means, what's the geometry? Tetrahedral. Tetrahedral's 2 in the plane, 1 out, 1 in. And so we try to put as many atoms in the plane of the board as possible. And so I'm going to put this carbon and this hydrogen in the plane. So this kink here is all in the plane. That's going to throw out a lone pair. One lone pair is going to be thrown out of the plane, and the other lone pair is going to be thrown into the plane. See that? It's like that. And so when we're looking at the angles here, the angles are, the HCH angle is about what? The HCH angle should be 109.5. The HCO angle should be 109.5. And the COH angle should be without distortions 109.5. But this one's going to be distorted because the lone pair is sitting on the out. So it should be slightly less. So we could say less than 109. It's a guesstimate anyway. But, a lot of books like this, less than 109, but how much less? A lot less, a little bit less? And so this is why I like to throw in the guesstimate about 105, even though it's just a guess. It tells us the degree. So we have, 5 minutes?
3.
3 minutes? 3 minutes.
Can you deliver by COH is 109.5?
109.5 is because it has 4 balloons. The 4 balloons are like this. It's the O has 4 balloons. The single bond balloon, lone pair balloon, and the lone pair balloon. What's the angle to maximize the distance between 4 balloons is 109.5. That's why. This is why the number of groups is so important. So the COH will be 109.5. So the geometry on this carbon, since we only have 3 minutes, what's the geometry around the carbon here? It's tetrahedral. Okay. This is the molecular geometry. It's tetrahedral. What's the molecular geometry around the oxygen here? Bent. It's bent. The electron geometries are tetrahedral and tetrahedral for both. The electron geometries are just a step to the molecular geometry. The molecular geometry is really ultimately what we're after, but we will need to know how to do that. And so this is the 3D Lewis structure for methanol. Can you redo this drawing? If I erase this, you could redo this drawing? Okay, good. All right. Well, their clocks are different. The exact clocks are different, but it's all right. We can get out early. Let's cut it. you guys looked at the practice test yet?
Practice now.
Not yet. We're gonna start looking at that.
Could you explain Vesper 1.5?
Vesper? Vesper is just these balloons.
Oh.
That's all. It's the repulsion between the balloons. You don't need to know what it stands for, valence shell electron pair repulsion. It's just groups of electrons repel each other.
That makes sense.
That's it. So this is a tool to generate all these, angles and geometries and that kind of stuff.
Yeah, that helps explain the angles better. Thank you.
Sure.